Hello, hello. Welcome to the show.
Good afternoon.
Let's see. Welcome here from outer space or wherever I am. Oh, we already got an early request here. Yeah, that's a good idea. If you got like, some people don't realize it, but you've got a lot of racket going on, which is okay because you don't have to, try to pay attention to mute your mic,
Right, you should just go right in there, right?
But
It was not so hard last time.
it's, I know you probably, Tony, you have little kids running around, whatever and whatnot, and you don't realize it. And I'd like to give it a couple minutes here before I finish rolling, but I don't know. It kind of worked out okay on Monday. I'll kind of check the chat. It's definitely a different environment for me. The only time I've used Zoom is question and answer and review sessions and stuff like that. This is the first time on Monday was I used it for lecture. Because, in a face-to-face class, if somebody...
Not enough in there yet?
What? Oh, well, okay. But anyway, in a face-to-face class, I can kind of, when somebody raises their hand, I can kind of control when I want to respond to it. It's a little bit different for this, so you can chat, you can, and, audio, but if obviously we'll see how it goes. If it gets to be too much interruption, then we may have to I may have to allow a certain points, certain stopping points for verbal questions maybe, but obviously you can type a chat question and I'll pop over and see what's going on. So we'll just kind of, see how it goes here. I don't plan on I'm actually using an old computer, kind of webcam doesn't work anyway, so I wasn't going to be putting my face on the screen even if it did. So it's not one of those kind of things where I have to actually look at you or anything like that or whatever. So no offense, and you certainly don't need to look at me. I mean, maybe one day I'll show my face on one of these or something, but main thing, it worked out well on Monday because let's get everything up on the screen and going. I haven't logged into, let me take a second here and going to log into my math lab. Got my notes down here up and ready, and let's see what kind of fun we're going to have here today. But I'm going to go ahead and log into that.
Professor.
That will be ready. And
Professor.
Yes.
I got a question for you. So in my stat lab, the work that's in there right now, I know you said that that's due before exam 1. We don't know what that is yet. Okay. I'm just waiting on that date.
Just probably estimate it's at least 4th week for sure.
Okay.
No later than the 5th.
But my question is, whenever we do take that exam 1 and we complete all that homework, then are you going to upload the next portion of the homework?
Oh, I'll have it. I'll get it. I'll have some of the homework done sooner than that.
Okay.
I'll have the homework done quicker than that. I'll have more of it done, so you don't have to totally wait. If you happen to finish or something. So, yeah, okay. I'll have that ready quicker than that, so you can move forward. But But I know what that homework due date is going to be. Just kind of, but keep in mind that as I mentioned, I'll keep mentioning that no matter what, you will get a chance to go back to that homework, but later on in the semester.
Okay.
So in other words, I want people to kind of move forward with the content we're on, but then give you the opportunity to go back and clean some up, later. So I have to look and see how many homeworks we have, and I'll make this announcement later. What I normally do, I'll drop a few like lowest scores or something like that, so then you can just, but we'll worry about that later. I don't know how many just yet. I can see how many assignments we had. Last semester, I think there were 18 assignments. I dropped the lowest 5, so the best 13 counted. So, but no matter what, you'll still get to go back and complete ones. 2 or 3 weeks before the end of the semester, I'll open them all back up. So there'll be no need to panic if you don't complete them. But I'll have those start opening the second ones up fairly soon.
Okay.
So that's that. But just kind of work. No panic or anything yet. You know, just kind of. I mean, really, it's nothing expected yet because this will be our first real show. You know, so we're going to get 3 sections done today. So whenever, you know, if we finish earlier than I did on Monday, then we're done because I'm doing exactly the same. I might be a little more efficient this time than I was on Monday. However, also I've tried, we'll see how it works at the end. I tried to set this up to where it records. So I don't know if it's going to work or not. We'll see. I may have to practice that because a lot of people were asking, you know, Monday, but actually this one, if it records and everything goes proper, it's just as good for anybody from Monday class to see it as Wednesday. In other words, you're not getting any big secrets that they aren't. So yeah. But one thing to note though is that starting next week though, the Wednesday class will be what I call the lead class because you'll be first in line for the content because next Monday is Labor Day. So even though we're in cyberspace, it's still an official holiday, so that class will not meet on Monday, but you will. Just like the Wednesday before Thanksgiving, you will not have a class, but Monday will. But that's okay. I mean, like I say, none of, you know, I'm not taking attendance or anything like that, so that's not a big issue, but I'll try to keep everybody. I'm just saying if somebody, but I guess if I just, well, if that's really if you wanted to attend live. I mean, if that doesn't matter to you, and assuming I have this recording thing figured out, you could decide if you just wanted to watch the lecture. But I'm just saying that you would, if you wanted to watch it live and you weren't going to be available on a certain Wednesday, you would want to watch it the Monday after that. Not the Monday before. Does that make sense?
Yes, sir.
Yeah, just because you become first because of that holiday. It's going to be really confusing for Monday because I keep telling them, well, you'll have to watch the Wednesday before, you know, you're not going to make it. So it's a little tougher for them.
Yeah.
All right. Well, we can talk more about that later. So we'll get the show started here and so that's what I did last time is I kind of went through these notes and then we worked on some, I forgot to finish getting the homework set up. I'll come back to that. And I always like to do, you know, homework problems. I think students seem to like that because then they can see how certain, yeah, we're not going to do every problem in every section. There's no time for that, but I'll try to remember to do the same ones I did on Monday, but it's okay if I don't remember which ones. All right, so I know you can't see what I'm doing yet, but you'll see in just a minute when I share the screen for you. I'm just logging into my math lab and getting, let's see, doesn't really matter.
Hello, I'm just joining in the class, sorry.
All right.
I just logged into the Zoom meeting. Hopefully I didn't miss a lot.
Oh, I don't know. I don't think so. I think you're fine. I'm just about to start the content part of it. So I was just more talking in general. So. All right. So let me get to the homework here and be ready, and then we'll go back to all right, so watch, we'll show you how this works now. So come over here. I'm going to share a screen. So I got to pick a screen to share here. Let me see if I can find, where are you, 2.1 right there. So I'll always just say, hey, you know, all of you don't all chime in yes or anything all at once, but I'll just, if somebody does, that's good enough for everybody. I'll tell you what screen I think is showing, and then that way you know, or If it's yes, main thing is if it's no, you know, that's more important than saying yes. Because if I don't, so you should be looking at just a screen of notes, let's say 2.1, organizing categorical variables. All right, no immediate no, so I'm going to take that as a yes.
Yep, that's the right page.
That's it, yeah. I just want to check because the last thing I want to do is be talking about something that's not, you know, on the screen. So it just takes me a second to toggle around a little bit. That's all right. But sometimes I might click on them. They put these bunch of little tiles across my screen, and they're so small, I might click on the wrong one. So, yeah, if you looked at those basic terms and definitions, you know, that's great. If you didn't, then that's all right too. But if you go back and read those, the two different types of data that we're looking at are quantitative and qualitative, which are, you know, words that sound the same, don't they? But quantitative is where data would be numerical. And okay, I think someone needs to kind of shut their mic off there or something. But all right. Well, not the audio for me. I meant just their mic. Data is quantitative, where you'd be collecting data that was just all numerical stuff. And the other one's qualitative. That's what this is. Categorical and qualitative are essentially the same thing, where you're collecting data that's, you know, in words, not numbers. Like this one is talking about, they asked millennials, define millennials between 83 and 2001. What devices do you watch movie or television shows? Well, obviously, those responses are going to be word responses, not going to be numerical responses. Now, there are some exceptions, and not, you know, anything I'm going to try to like do to you on a test or anything like that, but I always like to mention this. There are some exceptions to where, you know, numbers can also be sort of more categorical data than numerical. And it's like any sort of number that's used as an ID. I mean, or anything, you know, social security number, I don't know, driver's license number, student ID, stuff like that. Those are more used as labels. They're numbers, but they're really labels. In other words, nobody's going to want to take a set of data and they're not going to care what's the average student ID number or something like that. They're not calculated values. So that's kind of the exception where numbers would still be categorical or qualitative if they're used to label something, not something you would actually calculate. All right, so that I won't try to trick you with that on test or anything, but I thought that was all right, something's going on there. And this first thing's pretty easy. This summary table. This is just, so it's just showing you by percentages. By each device, 32% laptop, desktop, 10% smartphone, 9% tablet, 49% television set. Now this one, I'll switch over to the Excel thing I did. This is just one I yanked out of the book. This shows energy sources in the U.S. in July 2017. And it lists their numerical values, but suppose that we, you know, then wanted to express them as percentages. Well, that's easy enough. All you have to do is add them up and get this total number, which I did. Sometimes problems will give you the total, sometimes they won't. This one did not give a total. So I added those up to get that number 367,477. Then you just take each number, divide it by that total, and multiply it by 100. Let me pop over here. Let me see if I can find that. Oh, did I accidentally delete that one? I could do it again if I needed to, but hang on just a second. Oh, I'm about to switch for you here. Okay. Now, and there's a bunch of different ways you can do this. So, hey, what happened here? It's refreshing itself on me. Stop. This Excel file is freaking out on me here a little bit. All right, let's see if I can get this straightened out here. Now let me switch screens. Now I'm going to do a new share. And now you should see an Excel page. Like I said, there could be a bunch of ways to do this. And I find students that, you know, in my experience with teaching Stat 3309 a long time, students are pretty good with a lot of times better than me using Excel stuff. So, I mean, you don't have to be an expert or anything, but so what I did is I took this and drug these down and, well, let me do it, used, and that's this auto sum right over here where I'm pointing to the right, the top, and it adds it. Well, now it's okay. So it added up all the ones above it and gave me that number. And as far as the percentages, I just wrote. So I just take each one of them in here and I divide it by that total right there. Putting the dollar sign in front of the B, I didn't really need it in front of the B, but I definitely needed it in front of the 10. But anyway, it didn't hurt. That means it keeps that number fixed. So you see as I move down, it's taking, so B1, B2, B3, and it's all dividing them by the same number. And then I believe I came over here and picked that percentage right there to come, because it would have been decimal. I could have multiplied by 100. That would have also made it percent. But I believe I just clicked on that. Once I highlight all those cells, I just clicked on this percentages, and there you go. All the percentages are done. So back we go to the notes, and all right. Oh, this could be frustrating. Try this again. Sometimes this thing I want to share is not up there. It goes away. Where did you go? All right, bring this up, try this again. Now let me try to share it. All right, there we go. There we go. Now this, yeah, this part's kind of, these kind of questions, and I don't like to do these two really on an exam, whatever, because it's a little, you know, it's a little bit subjective. You know, it's kind of like on how you answer that, where it says, you know, what conclusions can you reach? Well, I think there's a lot of things you can say. I mean, like, for example, I think it's easy to say that the energy sources are dominated by coal, natural gas, and nuclear. Yeah, I guess that's as probably as good a conclusion as any. Or do we just say, well, you know, the main two then are coal and natural gas, and not even mention nuclear? So, but nuclear is so much more above the others, it's probably worth mentioning, right? So I try to avoid that for testing purposes. When that comes up in a My Math Lab problem or something, if you don't get it right, I mean, you can do it again, you know, in other words, so it won't be a big deal. So that's kind of, yeah, that's what I would say. I mean, unless there's a better explanation, but. All right, so that takes care of that then, so. Let's come on down and see what's next. A contingency table. 2 or more categorical variables that meet up by rows and columns. You might have, and this may come up even again in this class too, you might have seen this when you took the finite math and were doing probabilities and stuff like that. You might have seen these kind of tables, and I'll mention that here in a minute. I'll put this in the context of a probability statement. because we are going to be bringing back probabilities. That'll be in the second unit, part of the second exam. So let's take a look at this. So you see over here, so you have, what is this? Do you feel overloaded with too much information? This might be a good question to be asked you after this class today, right? So, no, just kidding.
Huh.
All right. Hello?
No, sir.
Are you saying something or?
Oh, no, I was responding to you, Professor. You said it was going to be an overload. I said,
okay.
I'm sorry. Sorry about that.
Oh, no problem. No problem. I didn't know if I was missing something there or whatever. So
No, sir.
let's see. So you see we've got the overloaded being yes and no. They're distinguishing between male and female. So you have like totals for each column. So you know how many males and females there were. And then totals for each row. Now, of course, keep in mind, they were polite enough. They gave us the totals here, but they didn't have to give us the totals because we could have just added down and got the totals. Like so, you know, we didn't have to be told. We just had to know for sure those 4 inner numbers. And then from there, you can get everything else. Now, they gave us the grand total right over here, the 1520, which was nice. But even then, we still could have done it without that 1520 as long as we had the inside stuff. So where a row meets a column, that means for this one, that would be somebody that a male who said yes about being overloaded. And the next one's a female that's overloaded. And to create these percentages, that's what part A down here said, complete these on percentages. Since there's 1,520 total, every number in there is divided by 1,520. In fact, that's why the last one's 100%, because 1,520 out of 1,520 would be 100%. So it's everything over 1,520. Let me show you. Let me go back to the Excel for a second. I think I still have that in there. Yeah, and so so you see here's where I did it in Excel. And I'm gonna zoom it. Oh, anyway. And so I wrote whatever. Yeah, so I just kind of, so this cell right, wait, oh, up here, that cell, the 1520, that's in position I4. So I use the $sign I, $4, and then every other number here is just divided. So it's G2 over I4, H2 over I4, everything over everything, all these numbers, then divided by that 1520, and then converted to percentages. I mean, you don't have to use it. I'm not saying you had to use Excel to do that, but it's not, you can calculate, you use calculator, whatever you think. Oh, let me come over and look at the chat thing for a minute here and see if there's anything. Well, I'll deal with some of these questions later here, I think, or whatever. Well, look at, there's going to be a few Excel assignments too. So look at the grade break. Somebody said, you know, look at the grade breakdown of the syllabus, and then ask me about. There's other stuff too. It's not just homework and exams. That's not correct. Yeah, I don't know what to tell you if the audio is not working. I don't think it's a problem that everyone's having though, or we would be having a big bad situation. So I don't know what to tell you from a technical standpoint there, but somebody had a nice suggestion there. Internet connection. I don't know if a different browser would help. I'm not sure if that would make much of a difference. So all right. I'm not sure what to say there. Sorry about that. Okay, somebody can hear me now. That's good. But no, you check that, the one that asked about the grades. Look at the syllabus breakdown carefully. I did not have it on that original syllabus, and I reposted the updated one that shows that. But wait till the end or something if you want to really ask me more questions about that, because I kind of want to stay focused on the lecture. That stuff you can ask me you know, like at the end of the class or something, so we can focus on the specifics and then jump on in later. Oh, I was going to mention this, like from a probability standpoint. How would you look at this? So let's say, for example, that you're selecting a person at random, and I'll use P for probability. What's the probability they were female and said not overloaded, said no? That would be, the percentage is also the probability, meaning if you just, so, you know, if they were all in one data thing, you selected it out, picked a person at random from a list. That means the probability that they said female and no to overloaded would be this percentage number written as a decimal. So that would be it. That's how this translates to probability. So so that the and represents where row meets column. So in other words, if you're just saying one thing, like what's the probability of male? That would just be the total. It's not specifying yes or no for the male. It means all males. It would be that bottom number of the first column, 5, 1, 6, 4. So forth and so on. And then, like, for example, the probability they said no would be 80%. Because you go across the no row there. I'll just put 0.8, put all the zeros there. So that's, you know, that might be helpful for you later on when we get to the actual probability stuff. Oh, yeah, over to the left. That was another, the part B, the what conclusions can you reach? All right, here we go. I don't know. I mean, let's see, what can we reach? Looking at the percentages. I mean, the females felt slightly more overloaded than the males. It's not really that significant, is it? It's not that much of a difference, but I wouldn't say they were strongly, you know, felt more overloaded, but a little bit more, right? Because that percentage is 11.18 versus 8.82, and that's it. Those questions are kind of a little bit vague. That's why I would never put those on an exam. Even if it pops up in my math lab, it's still tricky, but it's there are multiple choice questions, so you might be able to reason through it there a little bit. Okay, that's the end of this one, but now we're gonna jump over to, all right, before I switch you over, I'm gonna leave that there for a minute. Let me get that homework up and ready here. I have the section preview. So now, stop share, time to share. We got a question over here. Are we able to rewatch after a meeting? Well, this is the first time I've attempted to record something, so good luck. I don't know what's going to happen yet. If it works out like it's supposed to, the answer would be yes. If it doesn't, I'm going to have to, you know, get it figured out before next time and see what, you know, how that works. But I didn't do it on Monday because I hadn't figured it out yet or whatever. So Mondays is not recorded. But like I said, Monday and Wednesday, somebody said it is recording. I set up, you know, hopefully it'll be easy for me to figure it out. I have it sent to my computer. I'll see where they're going to put it. So I think the other option was it was a 30-day thing. Only you had to watch it for 30 days. It could disappear. But I think I picked the one where I'll be able to save it to the hard drive or something like that. So yeah, I got to once I upload it. So well, all I got to figure out is what the link is. You know, what the file is. That'll be easy to be. But once again, the video will be recorded. It will be posted. If I did it right. Yes. Yeah. If I screwed it up, then no. But yeah, once I figure out where it is, I can get the link, and the link part is easy. I put links in there all the time. It's just I've never actually done this before. Because I've posted my own lecture videos and stuff. So okay, I don't want to answer any more questions about that right now about the recording. We'll see. Hopefully it works out. Someone mentioned they saw that it was recording. I can't tell that, but I believe you. All right, let me get the business here. Back over to where we. All right, I don't know which one did I do on Monday here. Let's see if I should have written these down, but I don't think that one had too many. This one has five. I think I did that one. Yeah, I did that one. Let me go back. I think I did this one, but I'll go back to the first one, just kind of look at that. First one's super simple. Yeah, that's pretty easy. I don't know if I'd even waste my time putting that in Excel. You could, but simple calculator. So 15 and 7 and 28. So you got to get the total. Whoop-de-doo, 3 numbers. Excel is nice if there's a bunch of numbers. That way you don't have to add them up. You can let Excel do it. But those 50, so you just take each number, divide it by 50, and then you got to multiply it by 100 to make it a percent. Yeah, I didn't do this one on Monday. I just talked through it. But yeah, the one I did was actually the third one. So this one's already got the percentages for you. So it's kind of giving you, yeah, choices of which makes sense. I'm sure that one won't be too bad. Because you see this on this part A, it's giving you more specific questions instead of saying, or answers than saying, what conclusions can you reach? It's saying that what in the question, but it's giving you, some specifics to choose from, which is good. Yeah, that'd be the only way I would ask that on test. I mean, I could possibly list out multiple choice answers like that to where it would work. So let's do this one. This is the one I did on Monday night. And click over. Yeah, this was this the one that's I couldn't download it in Excel. I had to type it in Excel without, I don't remember. But sometimes it'll tell you to gives you the download to Excel option, but this one doesn't. Like I'll show you what I mean. We'll see it for other problems we do today. Like this one probably will. Yeah, open in Excel. It opens an Excel file. Let me see if I've already got these. Maybe I didn't delete these from Monday. Let me check before that would save us some time if I didn't. I don't remember. Let me go back and look at the other Excel. I've got 2 different Excels open here. That would be nice for Artie, because yeah, you don't need to see me type these in again, really. I mean,
I didn't attend the Monday class. Is this the first homework assignment?
yes. That is correct. What did, all right, where did this mess? Okay. Oh, yeah. Oh, the numbers might be different, though. That's right. It takes me a while to navigate my way around this stuff sometimes. So stop share. Let me share. The numbers might be different. Hey, now I've lost the Pearson screen again here. God, where do these things keep disappearing to? God, this thing is really annoying using this thing. I don't know where things go. They disappear on me. All right, I'll pick this button. Now let me try to see if I can bring it back up. Yeah, that's right. The numbers are different, so I'm going to have to. Are you looking at the homework problem on the screen?
Yes.
Yeah.
Okay. I wasn't sure if that was there or not. So, yeah, the numbers are different from Monday. So I got to type these in. Shame it doesn't download it to Excel. And then we just divide each one. So give me a second here. Can you see my Excel file up there too? No? Because I got screen and screen here. I don't know exactly what you're seeing, but you don't need to see it yet. So you don't see an Excel file up there next to it, do you?
No, we can see it.
Okay. Because it's okay if you couldn't have. I never know what. Because one time I did that, I opened up another file and people said no, they didn't see that one. So okay, this will make it a little faster that way. So I was just going to type these and then I was going to switch you over to this. But if you're looking at me typing in some numbers here, we're in really good shape because that way I don't have to toggle around anymore. That's what takes so long. All right, okay. 264, 450, and then I'll come up here, go down to right below it. That's where it'll put the sum. There's the auto sum over there, 2850, and that's in cell C8. So I'll go equal C1 divided by $C, $8. And then grab the corner of it, so we'll copy that formula down all the way to right here. And then where's that? Let me make this bigger here for a second. Where's my percentage thing? There we go. Oh, that's no good. I'm gonna need at least 2 decimal places. Percentage, decimal place 2. All right, now I'll shrink this back down. Just I remember it's 2 decimal places. Yeah, you got to be careful with this My Math Lab because it's pretty particular on what it wants in the answer forms. So if it wants 2 decimal places, on my exams are all multiple choice, but on the exams it won't be so difficult because as far as that goes, because you'll be looking at the answer, so you know exactly how many places they're in. You're not typing in anything. Here you got to. I've seen problems where there's like several parts to it, and one part will want 2 decimal places, the next part will want 3. So you just have to watch whatever it says. So I'm going to come over here, and we're going to type them in there. That went away whenever it did that, so I guess I'll have to go back and forth here now. Hey, when that does that. 15.82 is the next one. $15.09 and 8. I'll do 2 in a row. 15.09, 18.00. I don't know if I can remember 3 in a row. That might be challenging for me. 1512, 926, 1579. Got 9.76, 29 or 39. I'm going to double check this. I don't feel confident. Oh, 79. That's why I'm not confident. I guess 2 is my limit for memorization. All right, ready to check our answer? Let's see if we can get a happy green check mark here. I could just for fun try to guess what it's going to say. How about a fantastic? Give me a fantastic. Uh-oh, I'm wrong. Where did I screw up? Oh, Typo. 9.26. Okay, that's good. All right. First question, I didn't get the green. Come on, fantastic. Nice work, I'll take it. Green check mark is good. Beautiful. All right, it's going to ask conclusion, but these are going to be easy to read here. So let's look at this. Which one do you think has, I mean, obviously you can do it by number or percentage. Which automaker has the most complaints? Looks like D. What do you think? Okay with D?
Yes.
All righty, automaker D. Least complaints.
F.
I'm going with F. I like it. How about an excellent here? Good job, I'll take it. Very good. See, so that kind of, so when it asks it like that, it's okay, yeah, I didn't do this because it looks like this part C and D is just the same problem, type of problem, just different scenario. So we can skip that. I think that'll be good enough. So, okay. You basically saw the gist of how to do that. So if you can do that, I'm sure you'll be able to do this part of it. So we'll go ahead and move on. So what we're going to do now, what I generally do is, I'll lecture for a little while, stop and have a break, and then continue on. And we'll see if I've missed anything exciting in the chat. That one should have the Excel and the blue icon. Click the other icon again. Okay, well, that's, somebody might have had a good idea about that to get that thing to show Excel or whatever, but remember I couldn't open it up in Excel. That's all right. Would be nice, but we'll see other ones that will. So let me see if I've got the other one up here. Okay, let's see. Time to switch screens. Here we go. Share screen. Here we go. So I'll probably do a little bit this for a little bit and then probably stop and have a break. Share screen. So we should be looking at, let me scroll up to the top. Should be looking at a new section of notes here. 2.2, organizing numerical variables. All right, I'll take that as a yes, then that's okay. You don't have to all scream it out, so just make sure if it's not, when it's wrong, that's the key, right? Just go, no! Oh, you have to scream. All right, first thing here. Ordered array. Means just taking a set of data. Most of the time it's ordered lowest to highest, but there could be some situations where you might want to go highest to lowest. As somebody mentioned the other day, like for this one, hopefully it's for this kind of thing, I'm sure it will be like in the homework. And well, even on a test, I never ask gigantic data sets questions on a test anyway. So, but this one would, it's be kind of tedious. It's not hard, but taking all those numbers and rewriting them lowest to highest, it would get pretty boring in a hurry, wouldn't it? With 50 of them, I'd be bored pretty quick. But the concept's not difficult, I don't think. That's the important thing, right? So you take them, it's just put them, you just took both those data sets on the top, went lowest to highest, but Excel would be the right way to go for that. And we'll see if that, I think that's going to come up somewhere. If it doesn't, I'll just make up an example of numbers. I think that sort thing is going to come up in one of the homework problems, so we'll take care of it at that time. So now we're looking at how to organize numerical variables, meaning quantitative data. We're going to talk about something now called a frequency distribution. the frequency, so you're going to group these things. In this case, you can have individual numbers like this one, 1, 2, 3, 4, 5, and we're going to see an example, or often they're in interval form, like where it's between two numbers, 1 and 10, 11 to 20, between some numbers, not two numbers, but two numbers in an interval, 21 to 30, and so forth. Frequency means how many values that fall either to, in this case, a specific number or within an interval that we'll see coming up here in a little bit. So this is a nice little example to start off with where it's just single numbers. I just made this data up here where there's a number of courses taken by 25 random UHD students shown below. And you look at this block of 25 numbers. Now you can see that they range anywhere from 1 to 5, correct? Nothing outside of that. So that's why I put in 1, 2, 3, 4, 5, because those are the only options. There's nothing else. Now, the frequency then boils down to counting how many belong to each one of those. So let's see what we got here. Come over here. I see a 1 right there. I see another 1. Those are the only ones I see. So that means there's 2 of them. So we've got 2 right here. Let's try it for 2s. There's a 2, 1, 2, 3, 4, 5. 5 2s. Let's check the 3s. 1, 2, 3, 4, 5. 5 3s. 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And the 5s, we have 1, 2, 3, and 4. And that would be your frequency distribution for this particular set of data. Now I went ahead just added these up, and I got 25, and we had 25 numbers. While this is not difficult conceptually, anyone, including me, can make a mistake. Your eyes might trick you there or something, or you missed one visually. And then if you go, like say, if you went over here and counted these up and it added up to 24, then you would know you missed something somewhere or whatever. So if you did it and you end up getting about 17 or 18, then I would strongly suggest that you probably need some sleep or some relaxation or something, because your brain's not quite working right, But missing it by 1 is not a big deal. But yeah, so it's not hard, but it, could potentially be mistakes made. All right. Relative frequency takes those frequencies and divides it by the total, meaning it's sort of displaying a proportion of observations in each class relative to the total number of observations. And we'll see that on the next page as far as calculating it. That's just the definition. And this one, to understand the next one, I think you really need to see, which I'll show you in a minute. Watch me walk through the example. Well, there's cumulative. I should have put cumulative frequency on there also. I don't know why I didn't do that, but it's the same kind of idea. I should probably have a cumulative frequency definition in there, but you'll see what that cumulative means here in a minute. But it's kind of like a running total. It's less than or equal to whatever group you're observing, plus everything below that. All right, so let's take a look at this in an example. This is probably the same example, actually. See, I included the cumulative frequency column here, but I forgot to actually define it. But that's okay. So this is the same data from above. Now, relative frequencies, it's kind of, mathematically, it could be expressed as a fraction, a decimal, or a percentage. But like I said, on an exam, you're going to see from the choices how it's going to be expressed. And my stat lab, you do whatever it tells you to do. But I'm just saying, mathematically, there's 3 ways it could be shown, and they would all be equivalent. I didn't put the only one I left out the percentage, but okay, but I put the fraction and the decimal. But that's not, 0.08 would be 8%, 20 would be 20%, so forth. So you see what it's doing is taking every column in the frequency, every number in the frequency, and dividing it all by this total, 25. That's how each of those are being calculated. And that adds up to 1, essentially meaning 100%. In other words, 100% of your numbers are going to be represented by 1, 2, 3, 4, or 5, which that's correct, obviously. You don't want to have anything missing or something. So now I'll jump over to the cumulative frequency. And then go back to the cumulative relative frequency. This is a little tricky, but then once you kind of get there, we're going to do an example of this in the My Math Lab homework. And don't, if it tricks you a little bit, don't feel bad. It's kind of weird. Once you get used to it, it's okay. But we were having a little bit of issues on Monday with not everybody, but a few people. All right. So the cumulative frequency in the first row is always going to be whatever the frequency is, because there's, when I said earlier, I said below, I meant less than, not visually below. It's above visually. But see how this, it's a running total. So when you get to this 2 courses, what you're saying is how many people are taking 2 courses or less, 2 or 1. So you take the 2 plus the 5, and that makes the 7. So it's a running total of whatever row you're on plus everything below that. Visually it's above, but numerically it's below. Does that make sense, hopefully? I got to be careful with the below and the above because it's below numerically, but above visually. Now, the cumulative at 3 would be adding 3, not the numbers 3, 2, 1, but the value, the frequencies for 3, 2, and 1. So 2, 5, and 5 be 12. The next one, for 4, you'd add up 4 and everything above it. 2, 5, 5, 9. Add those up, you get 21. And then the last one is going to be all 5 of them added up. So you never have to add up all these numbers. They don't mean anything. But it's important that the last number in the cumulative frequency does equal the total of the frequencies. Now I'll show you, there's a little quicker way to do it. Once you have this first 2, all you got to do is just zip over and go 2 plus 5 is 7. You just can keep adding the next number. I was just showing you adding up the individual numbers the first time. Then go 7 plus 5 is 12. 12 plus 9 is 21. And then 21 plus 4 is 25. Now the cumulative relative frequency works the same way. It's just using the relative frequencies to do it instead of just the regular frequencies. All right, so if this is 0.08, that's going to be 0.08. And then we add the next one, which is 0.20, and that'll give you a total of 0.28 for the first 2. The next one also happens to be 0.20, so we add another 0.20, we'll get 0.48. Add the next one, which is 0.36, we get 0.84. And then plus 0.16 is 1.00. So you see the same thing, the last number here for the cumulative relative frequency matches the total for the relative frequencies. So that's going to be fun. After I'm going to go ahead and define, yeah, let me go ahead and go through this. Yeah, let's go through this a little bit, and then I'll go to the homework. That way we'll kind of see everything when we get over there. Now we're going to look at another type of bar graph here coming up for categorical, but this is a special type of bar graph. A regular bar graph can be used for qualitative data. That'll be in the next section. But a histogram only applies to when it's numerical data. quantitative data. And how you construct a histogram, or in your case, generally picking the right answer, whether it's a test or a homework, but you're still kind of constructing it, but your art skills are not required for this class. If you understand the concept, that you don't have to be able to draw it perfectly. So the way you do it's not too difficult. Now, they can be done one of two ways. I'm just showing you this visually. Most of the time, the bars are connected. It's most often like on the right. But you haven't violated any laws of statistics if you do it the way on the left. Well, let's take a look at how this works. It's based on up here. Now, you see these numbers, the frequencies, 2, 5, 5, 9, and 4. I knew the largest one was 9. So I just went up to 10 for the heck of it. I could have gone, I went by twos. I could have gone 1, 2, 3, 4, 5, 6, 7, 8, 9. Do I have enough room? I will try to stretch this out a little bit visually. Not sure if I've got enough room to move this up. I'm going to try to get it to line up a little bit better. Get the 10 up on the line and see if I can get everything else. Yeah, just shrink it. Stretch it or shrink it like that. This isn't going to work, I don't think. Well, actually, if I press it in and drag it, that could work. Oh, that's actually going to work right there. I can bring the whole thing down the line. Yeah, that looks better visually. See, that's probably what I did when I copied these over from my old notes. I just didn't bother to get it lined up properly. Move it up a little bit here. Anyway, all right, I'll quit playing around with this now. So I'm going by twos. So what you do is you take each of your, oh, I lost the 5 here, didn't I? I can draw it back in there. So the courses are all on the bottom. And then the heights of each bar are the frequencies. So the y-axis is the frequency. So you see that one course had a frequency of 2, correct? So I just drew me a little bar. You center the one right in the middle. Went up to a height of 2, went over like that, shaded it right in there, and there's the first one. Next one, the next 2, in fact, are both 5s. Now, because these go up by 2s, the only possible number, it's a little bit different if it's scaled different. It would kind of have to show you the numbers, or you'd have to approximate that. It won't, nothing you have to worry about. But there's no doubt that bar height is 5 because there's nothing, no numbers between 4, no whole numbers between 4 and 6 except 5. So we got 5, 5. This one's between 8 and 10. Might be a little tall there. Don't worry about that. But it's 9, and then that one was 4 right there. So 2, 5, 5, 9, 4. And here's the same thing on the right. Just the bars touching each other. Our first histogram, isn't that exciting? We've got another one coming up here too. Now we're going to learn about group data. This could be exciting. Hopefully I haven't put everyone to sleep yet. Anyway, let's see. 30 data values, just data. I didn't assign them any kind of meaning or anything like that. Good. Group data means kind of, I said this verbally earlier, write it down. That's if you had like, 1 to 10, 11 to 20, 20. So it's not single values. Like the courses is single value data, 1, 2, 3, 4, 5. This will be put in intervals because this would be kind of ridiculous to put this as single number, and especially if you're trying to do a distribution, frequency distribution. Yeah, it wouldn't work too well. It works fine for 1, 2, 3, 4, 5 because there weren't many. Those were the only numbers, and you just were counting the repeated numbers there or whatever. But this would be ridiculous unless you use intervals. Okay. So we want to know what's the best number. Classes means how many rows of data. That would be 5 classes of data. So we want to know what's the best, because you don't want to have too few. You don't want to have too many. Too many classes. Like you wouldn't want to have one that starts at 7 and go from 7 to 8, 9 to 10, 11 to 12, 13 to 14, all the way to 53. That's too many. You don't want that. So somebody came up with this little formula to kind of give you the optimal number of classes. Sometimes the problem may tell you. So if it tells you, use whatever you're told. If it asks to do this, then do this. All right, so it's kind of a scary looking math formula there, but don't be afraid. 2 raised to the k power greater than or equal to n. It's not bad. K is going to be the number of classes, the smallest number of k that will satisfy that. N is the number of data values. So my data on that other page, there are 30 numbers. So 30 is my data. And I'm going to find, and you can obviously don't just check it. I got an output for you that you can use down here, real convenient. You can use this anytime. But anyway, just to show you, I just did this on purpose. Started at 4 because I knew that wasn't right. 2 to the 4 equals 16. 16 is not greater than or equal to 30. But then I put 5 in there. 2 to the 5th equals 32. That's the first time you hit one greater than or equal to 30. So that's what they mean about the smallest one. You don't want, every number after 5 you put in there would certainly make it greater than 30, but you want the smallest one where it does that. So you would want the 5. So 5 would be the best choice for the number of classes we should have. So, okay, let me see if I can zoom in on this a little bit. So now I'm going to give you a quick oral quiz. Obviously, I didn't, I'll let somebody, we discussed this one on Monday. It's kind of interesting. Don't feel bad if you miss it. First couple people missed it and somebody finally got it right. So the left column in this, you see, that's the 2 to the, that's the X or the K. The X is the K. 1, 2, 3, 4. So you see there, you see the 2, there's the 32 right there. So 2 to the 4 is 16. 2 to the 5 is 32. So 30 fit right in between those two, and you want to use the 5 for the number of classes. All right, so you ready to test yourself here? Okay. Suppose we had 200 data values. What would be the correct choice for K, the number of classes? Anybody can just shout it out. Anyone?
The 4?
Not 4, because 2 to the 4 is 16.
So 8.
Winner. It's 8, because 200 fits between 128 and 256, doesn't it? So you go with the one above it. So it goes to the 8 because that's 2. Because 2 to the 8 will be the first time it will be bigger than 200. That's all you got to do is just wedge your number in between the two numbers, then you pick the X. That's the larger of the 2. So 8 is correct. Very good. Somebody brought their math skills to class today. Yeah, okay. See, I told you. Friendly little question there to see. So, all right. Talk about some things here. Class width. We have something called class boundaries, which are going to be the minimum and maximum value.
Mm-hmm.
Hello? Hello? Okay. Class boundaries. It's the minimum and maximum value for each class, meaning each class, each interval. It'll be the smallest and largest number for that particular. Yeah, when we say class and interval, we kind of mean the same. Well, you see I put it in parentheses right here. I guess I forgot to do it up there here, but it's class and interval is the same thing. Class width would be the difference between the class boundaries of each class, how far apart they are. Now, let's look at taking a data set. What would be the appropriate class width? We're about to take that block of 30 numbers I showed you a minute ago, and we're going to create our own little frequency distribution. It's going to be lots of fun. Well, 30 numbers is fun. 300 would be torture. All right, so here's what you do. Take your data set. You take your maximum number and your largest value in there. You subtract your smallest value, and then you divide by the number of classes that we would have found before. We just did that, 2 to the k business. That's what we mean, the number of classes. For the problem that we're working on with that data, it was 5 classes. That was not the one I said, 200. So we have 5 classes. Now, you must round up. That must be important if I put it in red and big letters and all caps. It doesn't mean I'm angry, it just means it's important. Don't feel threatened. Now for as far as you're concerned, the way we're going to do it in here is the next integer. That's what you're going to be concerned with. But let me explain, like I did on Monday, what the or useful number actually means. We're not worried about that in this class, but I want to explain what that means. Suppose you were doing your own personal frequency distribution, and they were like large numbers. That's where this usually comes into effect, is with large numbers, like triple-digit numbers, big, larger values. Well, let's say you calculate your class width was like 88 or something. You might want to use 100 just to make it look, 1 to 100, 1 to 200, to make it look like pretty like that or something like that. So it is possible that someone could take a frequency distribution, so next might round it up to a little bit more. But in our world, don't worry about doing that. We're going to the next integer. For example, let's say you perform this calculation right down here, that formula right there, minimum, max, minus min, divided by number of classes. If you got 5.1, you'd round up to 6. It's not normal mathematical rounding. It goes up to the next integer regardless. Now, I bet you're dying to know why that's true, why that's necessary. I'm going to tell you that. It's not just to have a little fun with you and make your life difficult. There's an important reason. I wouldn't do this if it tortured you. Well, anyway, let's look at this calculation. I got to scroll back up. So I'll tell you where the 5 is coming from, and I'll show you where the other. The 5 is the number of classes that we found right here. So we go through our data list. Now, I remember when I created this data list, I intentionally put the largest number near the smallest number so it'd be easy to find. Well, there's 2 sevens, that's okay. But you can double check, but this is the same one I've used before. But 53 is the largest number in that set, 7 the smallest. So that's where those are coming from. 53 minus 7 divided by 5, 9.2. We must round up to 10. Our class width would be 10. Because here's what's going to happen. I'm going to explain how to build these intervals here in a second. We're going to look at them right now, though. Here's why you got to round up. So one of the rules of these frequency distributions is every data set needs a home. It needs a place to go. If you round down and you build that little classes interval thing I have over to the right, you won't, the largest number, 53, will not have a place to go. It will not fit. It'll be larger than that last row. But rounding up, ensures that 53 will have a place to fit. That's why it's crucial. Now, once again, in our world, we're going to do it this way, but you know, it's, let's say when I was talking about those largest numbers, big numbers earlier, that's a rounding, a useful number. Well, somebody might want to go from starting from, you know, 1 to 100 or something like that, even if that wasn't the smallest number. But what we're going to do on ours, we're going to start the first row with the smallest number of that in our list, which was 7. We're going to start with 7, and then we're going to use this class width of 10 to space it out from there. 7 to less than 17. Let me explain what I'm talking about. So this by doing it like this, I guess I could just put a less than symbol. It's a lot of wording there, but 7 to less than 17 actually means this would work for whole number, integer data, or decimal data. This would work because if you, this first row represents, suppose you have like 16.99. That would fit in your first row. But then as soon as you jump down here, that's where 17 actually belongs in the second row, not the first row. It would be to anything less than 17, but not equaling 17. Equaling 17 jumps down to the next row. Because that's good, because that's one thing you can't have in these distributions either, is you can't have one number fitting in more than one place. But it doesn't. Just because they both say 17, 17 only belongs to the second row. But 16.999 or something would belong to the first row. Our data, when it's whole number data, somebody could just say 7 to 16 if they wanted to, and since they know there's no decimal value, so it can be done that way too. But this works whether it's decimal or not decimal. So we just go by tens, and we know there's 5 classes. We already figured that out. 7 to 17, start at 17, go up another 10 to 27. 27, go 10 more to 37, 37 to 47, and then 47 to less than 57. So guess what now? That 53 is going to have a place to go, isn't it? That 53 is going to fit in that last group. Otherwise, it would not have. All righty. Let's talk about the frequencies. How much we're going to take a break here in a minute. Yeah, I'll come back. We'll take a break in just a minute, and then that's when we'll start the My Math Lab for this section. But let's get this thing built first. So this says 7 to less than 17, which because this is integer data, that does mean 16, but I've already explained if it had decimal data, you know, you would include any 16 point something. So what I got to do, here's what I did on Monday night. I just used dots to do it, and I erased them, so we'll do it over. 7 to 16. So I'm going to put little dots next to them. Well, we'll go red the first time. So you're looking for anything, the one we did earlier, we're just counting all ones, all twos, all threes, blah, blah, blah. We're looking for anything that's 7 to 16. And like I said, conceptually, excuse me, it's not hard, but, you know, your eyes can trick you. I've made mistakes here before. So there's one. I think that's between 7 and 16. I want to dot that one. Here, here. 10 fits, 7 fits, 13 fits. I think I found everyone that's between 7 and 16, correct? How many dots do we have there? I count 8. Anybody disagree with that, or is that okay? Or I like it. I like 8. So I'm serious. I mean, I could be wrong. Well, I mean, my result down here is right, but I could have just counted them wrong. What do we have down here? We have 8. So there are 8 of them in that interval. So you sort of see that now. So 17 to less than 27. So I'm looking for 17 to 26. I'll use a different color dot this time. I'll use purple. 17, that fits. 21, 24, 18, 20, 22, 21, 25, 18, and 21, between 17 and 26. How many purples do I see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you think? 10 purples? I'll take that as a yes. There's 10. Do you need me to go through the rest of those?
No.
No, we're good, thank you.
Yeah, that's okay. I don't want to embarrass somebody they did, but I went to the first two, and Monday said, okay, they wanted to see the second one, you know. They were glad to see the second one, but then they kind of had the gist of it. So really, it's just a matter of not having a brain fart, you know, not seeing a number or something like that. But I don't think conceptually it's too complicated. I mean, I know. It's probably annoying when teachers say that, isn't it? This advanced calculus is not easy. No, I'm just kidding. But I mean, come on, we're all, you know, intelligent. But this is not exactly, yeah, you know what I mean. So
I have a question. You know how you did 7 through 17, but you actually did 7 through 16. Why do we do 16 instead of 17?
Because you can't have 17 fit in two places. So 17, if there was a 17, it would have fit in the second row.
Okay, got it.
Right. So you can't include that one, yeah, because they can't. I'll show you his definitions here in a minute, but yeah, you can't have one value fit in two places. That's because but if they're decimal data would have been covered. You know, anything 16 point something would have also fit here. But once you hit exactly 17 or higher, you'd go to the next one. So they got to fit in only one hunk. I know it looks confusing the way that's labeled, that 17 might belong in both places. It does not. The left-hand column is where the number would belong. Okie doke. Relative frequency, easy enough. You're going to see me do it. I'll kind of skip the cumulative here because you're going to see me do a cumulative in a MyMathLab problem here after break. So, but if you can ask me about it later, but you know, that's kind of tricky, but of course where you keep the running total. You know, 8 plus 10 is 18, plus 4 is 22. Oh, here I am doing it. Plus 5 is 27, plus 3 is 30. So, let me show you the histogram real quick, this definition, then we need a little break here. Oh, I forgot to explain this zigzag thing on Monday, so it's not important, thank goodness, but. So here's how you do it for this. You know, instead of when it was single number data, like when we had the 1, 2, 3, 4, 5 earlier, you center the bar over the number, but when it's an interval, you draw the bar like this interval, you draw a bar between the two numbers in the interval. Now we know, even though it's both touching 17, we know by the way the thing is designed, we know that 17 does belong to the second bar, not the first bar. So because histograms, we like to connect them if possible. I like to connect them. And the frequencies are just the heights. 8, 10, 4, 5, 3. Let's see if that was, yeah, 8, 10, 4, 5, 3. And, here's what that squiggly thing means. It's not anything important, but let me tell you what it means. Suppose you had like really large data values, you know, 100 and up, and you were building one of these things. The little zigzag thing kind of means sort of like a fast forward, because a histogram would look really stupid if you started the bars like, you know, 3 or 4 pages over to the right of the axis there or whatever. So sometimes they'll just do that, you know, like if that 7 would have been 100, we're saying, okay, we know it's not really 100 spaces over. Does that make sense? You know, it's not scaled. You know, you want the bar width to be the same once you start it. But it's okay, we're going to fast forward, and here we are at 100. So that's not important. That'll never be on a test or anything, but no concern. And this is just some, you know, this is what you kind of want. Equal size classes, everything to be equal with. Mutually exclusive, that's what we had the question a minute ago about the 17, for example. You can't have, one number belonging to more than one class, but the way we did it, they don't overlap. The 17s really weren't in both places. Okay, include all data values. You don't need to know these by definition, void empty class. Okay, main thing's the first couple of them there. That's the important part. So I wouldn't worry about the rest of this. So, all right, I think let's have a break. I need a break for about 10 minutes. Is that all right?
That'll work.
About 10 minutes, we'll resume around 7.
Yes.
When you hear me talking again, that's when you know we're kind of back. And, we'll start with, we'll go to my math lab. I'll get that set up here in a minute. Be ready for that. All right, guess we'll let the games begin here. No, you're as excited as you can be, right? All right, so hopefully you should be staring at a homework problem from section 2.2. Yeah, I did this one on Monday. I'll go ahead and address this in case somebody was going to ask it. We'll see. It's because I asked them on Monday. They really didn't need to put this part about the upper boundaries being 99, 119, and so on. That's kind of confusing, but I can explain why that is, because it's been based on what I've been talking about right before break. Is you see they've already got the intervals laid out for you. Because you can see this data is all whole number data, the 80 but less than 100 really is the same as 80 to 99. So that's why they're showing that was not necessary to leave it. It was fine leaving it like this, really, but they threw that in there. So that's all it means. It's the same thing as saying. But I'll show you for a second a problem that I'm not going to do. I'll save that one for you. But they actually wrote not this one, but yeah, you see how this one they had it just kind of done that way because their data they know it's all whole number integers, so there's no chance of a decimal value fitting in there. But I thought that was kind of unnecessary to put that in that problem that we're about to do. It just could potentially add a little more confusion. So this one, you got a couple of options here. Being only 30 numbers. Yeah, there's a lot more numbers. You can maybe count them and do it without the Excel, but this is a good opportunity for me to dump the data in Excel and sort it so you can see it. But for this smaller set of numbers, you felt like you could just count them yourself. That's fine. So you have options here. I'm going to open this in Excel. So let me, do you see the Excel screen or not?
I don't see it.
No.
Okay, that's what I'm saying. Well, earlier I did one with an Excel and it was there, so I cannot figure this thing out. Okay, that's what I was wondering. I was surprised when you actually saw it earlier. So I'll stop and we'll switch over. That's fine. All right, so I'm going to select that entire column. I'll come over here, do a data sort, smallest to largest. And then there we go. Count them up. Yeah, I think on Monday I just kind of highlighted them as 80 to 99, and I'll do that again, I guess. I don't want red, that's too much. Oh, no. It's the fill I want to be yellow, not the. That's my 80 to 99, and then my 100 to less than 120. $120 to less than $140. So we don't include 140 there. Next one will be 140 to 159. $160 to $179. Yeah, you don't need to do all this coloring part. All you gotta do is just count them up. But I just thought showing you it might look interesting visually. And 180 to 200 or 199. And then I'll start reusing colors here. And then 200 to 219. All right. So what do you say? Yeah, you don't need to color these, but the first frequency is going to be 3, correct?
Yes.
3 of them going to be in there. So I'm going to, and what I'm going to do is I'm not going to switch screens. I'll leave this big screen. Leave this as. I'll just go enter and then I'll switch back over to my map. You can, so I'll tell you what I'm doing, then we'll switch over where you can see what I've done then. So 100 to 120 looks like 4. 100 to less than 120. So now I'm putting 4, and like I said, you'll see all this here in a minute. 120 to less than 140, and scroll down. Don't scroll down yet, but wouldn't hurt. I see 6 of those green ones there. So I'm going to go with 6. And 140 to 160, 7. $160 to $180. Or less than 180. I see 6. Well, let me just do the last 3. So 6, 2, 2. Let me get those numbers in there, then I'm going to switch and let you see what I did. So let me switch over to the homework. All right, so you should be looking at the homework problem then. So I just entered those numbers in there for the frequencies. Let's see how I did. Nice work. Woohoo! How about that? Not too bad. Now I just want them as percentages. So like I said, this is up to you how you do this. You might just, this way, I'll do it the way I did it. I just did it with a calculator because there's so few of them. And so I'm going to switch screens here on you. And there were 30 numbers total. Oh, I don't have to do it. Wait, gotta wait. For some reason my calculator wasn't there. One of the options. Now hopefully it will be. Yeah. Sorry, I was doing the same problem. So let me go back and look over, and so they're all going to be divided by 30 because it was 30 numbers. I'm just switching over a look. So 3, 4, 6 are the first three. And I can either just move the decimal over or put 100 here if I want to. That's my first percentage, 10. 4. 6. 'Sometimes on exam, I mean, I just go ahead and put the decimals in there. You know, it may not be needed sometimes, but I'm going to do it anyway. I don't want to take a chance on upsetting my stat lab there. So I want to put 10.00 there when I get over that. So, but it may, when it's exact like that, I think it's 2 decimal places. Let me check. So what I'm doing right now, you can't see it, but you'll see it here in a minute, is I'm putting this percentages in. I'll get over and let you see all of them after it's done. 10.00. This one was, next one was 13.33. 2 decimal places, yeah. And I'll put 20.00. Now let me go back and look up here the next set of numbers. It was 3, 4, 6. 7, 6, 2, 2. Well, 2, 2 will be the same. So all I got to do is 7, 6, and 2. Well, and I've already done 6. So let me just do 7. And really all I got to do is 7 and do 2. Because it's going to be twice, and 6 is going to be twice. And there we go. So it's 23.33. Now I'm going to switch over. All right, so you see I've done some of them right there. All right, let me double check which ones. Wait, I gotta check the above up here. So what are these numbers? 3, 4, 6. So the fifth one is also a 6. So I can put in 20 here. And the last two were both 2s, and that calculated to be 6.67. And that was the 23.33, I believe, because that's the one that had the 7. All right, let's check it. Beautiful. Hooray. All right, this one, bugged me. It's cumulative, but I don't like that they started at 80. That makes that really kind of confusing, because if you're going to start, because it says less than 80, and I'm going to get this right because I got it right on Monday, but you would think the first one would start with this one right here, less than 100, and the answer would be 10. But less than 80 is going to be 0 because there's nothing less than 80. So it's just going to be a weird looking cumulative, because then it's going to be normal after that, but it starts out with 0 on the first one. It's also 2 decimal places. Weird. That was unnecessary to put that started at 80. Now we go back up here for the cumulative. So that now it'll be, the first one will be 10. .00. And then all we have to do is add the next number to that. So you take 13.33, add that to the 10, that'll give you the less than or equal to for that one. You're going to get 23.33. Now for the next one, we take 23, the first two, 23.33. Now add the 20 to it. That's going to give 43.33. So we're just adding the next number to it. And then our very last one needs to be 100%. So we take 43.33 and we add 23.33. And we're going to get 66.66. Now here's where there could be an issue. Not that's not the issue. Because of rounding and that sort of stuff, it's probably going to really be 66.67. Hopefully it will accept this answer. But the problem, watch when I go down, I better change that to 7, because it's probably not going to add up to 100 at the very end. It'll be like 99.99. But I wonder if it would accept it as 66.66. You know, another way you can do this is to make it more accurate. And I'll show you, I'll switch over to the calculator, is you can do it with the frequencies and divide by the total. So if I took, we're on the 160 row here, right? Let me look, which one are we on? 4th row or 5th row? We're on the 5th one, 160 and less. Oh, it's because it has that extra 0 row. It's the 4th one here. Well, if you take 7 plus 6 plus 4 plus 3, that is 20 out of 30. Switching over to the calculator. Oh, there we go. And this is going to be 66 point. But it's because of rounding. Because if we added those 3 3s together and got 6 6, but had we added 3 3 3, we would have got 6 6 6, which would have then rounded to 6 7. So it's really 66.67. That's a little sneaky. So now you know to watch for that little trick. So I'm going to go 66.67, which I believe is a better answer. Now, I'm going to go, well, I guess I can keep doing it with the percentages again. So 66.67 plus 20 will be 86.67. Oh, this is going to be off again. It's going to finish at 100.01. So maybe it is better just to keep doing it with the adding up the frequencies and dividing. Because you add 6.67 to that number, you're going to get 93.34, which is, it's really going to be 93.33. I guess the idea is just realize that they're either going to be 6 sevens or 3 threes. And not, you know what I'm saying? When you add them up, just change it. And then now you add 6.67, it's going to be 100%. But that's a little weird. Check answer. Got it. What amount does monthly cost seem to be concentrated? Yeah, okay, let's be careful when we look at this. We want to go back either to the, we either want to go not the cumulative, but either the frequencies themselves or the percentages will be fine. Most concentrated. To me, it looks like those middle three. What do you think? I think it's going to be between 120 and 180. Seems to be most concentrated around there.
I'm sorry, are you still on the MATLAB or whatever?
Yeah.
Okay, because I'm seeing the calculator screen.
Oh, of course. Okay, sorry. Yeah, let me know if you're on the wrong screen because I was through with the calculator screen. Oh, sorry about that. Anyway, so that's what I was talking about. I changed that 93.34 to 33, and then the last one fit at 100. So those decimals should either be 0.67, 0.33, no matter if they add up to be a little bit off. All right, sorry about that. Well, I got the green check mark for that. But anyway, so now here's what we're looking at. Where now, because yeah, now you definitely need to see this right here. I'm thinking they're concentrated mostly between 120 and 180. You can kind of see that's the 3 biggest percentages, correct? Let's see if that's an answer choice. Hopefully it will be.
You said 120 through 180?
Yeah, you see that's the 3 biggest ones are kind of together there, right?
Yeah.
It's that's kind of where is it most concentrated amongst the highest, usage there. So I'd kind of put it at 120 and 180. I mean, obviously the highest single month is 140 to 160, or single cost. But I think it looks like, it's good. 2/3 of them, or not quite 2/3 because it's 63%, but a little less than 2/3 of them fit right there in those middle 3. Let's try that. Well, okay, that's a choice, so that's good. Hopefully it's the right one.
Fantastic.
Hooray! Wasn't that tremendous? All right, so we're through with this.